Hello, we're going to pick up again where we left off. So I was in section 8.5, estimating the difference between two population means, and we now will turn to an example. So we're going to do section 8.5, an example of estimating the difference between two population means. A nice example I found in the textbook is 8.56 hotel costs. So there's some data that's been gathered for the hotel costs example, and I believe this is data that we have looked at before. So we have three different hotels: Marriott, Westin, and DoubleTree hotel chains, that is. And we have a sample average nightly price for a room. $150 is the sample average at Marriott, $165 for Westin, and $125 for DoubleTree. And to do any useful statistics, we also need to calculate the sample standard deviations or variances. In this case, it's standard deviation. As I mentioned, you need to pay attention to whether it is variance or standard deviation. In this case, we are given standard deviations. 22.5, and that's supposed to be a decimal point. Come on, decimal point. There, and 12.8 for DoubleTree. Okay, so just one note, I'm just going to underline, make sure that everyone knows that that is a standard deviation. Finally, we need to know the sample sizes. And we read the problem here. It tells us that the means and standard deviations for 50 billing statements from each of the computer databases of each of the three hotel chains are given in this table. So 50 is the magic number, and it is the same in all cases. That isn't necessarily the case for these types of problems. Our formulas will work if the sample sizes are different. Sometimes they're different, sometimes they're the same. It doesn't matter, we just use the appropriate formula. One other interesting thing to note about this is that there are three hotel chains, and the ideas of this chapter are about comparing two things. So we cannot compare all three at once using the ideas of section 8.5. We have to compare them in pairs. So we're just going to compare Marriott versus Westin, and then we're going to compare Westin versus DoubleTree. So we're going to do two comparisons of pairs. We can't do all three at once. There are ways to deal with 3 or 4 or many populations. We will start to look at that in chapter 11. But for now, we're only going to do two populations at a time. So I'm going to ignore the DoubleTree data while I compare Marriott and Westin, and I'm going to ignore the Marriott data while I compare Westin and DoubleTree. All right, so let's now turn to the part A of this problem. Part A is to find a 95% confidence interval for the difference in the average room rates for the Marriott and the DoubleTree hotel chains. So I'm sorry, I said Marriott and Westin, but we're actually comparing Marriott and DoubleTree. All right, so Marriott and DoubleTree. Let me just write this down. 95% CI for the difference in average room rates between Marriott and DoubleTree. So we're just going to ignore the Weston data in this comparison. The formula for confidence interval is the difference between the sample means plus or minus the z sub alpha over 2 coefficient times the standard error. All right, now it's really just a matter of filling in the blanks. It's pretty straightforward. So note that we're going to call x1 Marriott and x2 DoubleTree, 150 for Marriott, 125 for DoubleTree. And that is going to be 25. And so that is what we see as the difference, that Marriott is $25 more than DoubleTree. That's our point estimator. That's our best guess for a single number that would represent the difference between the Marriott and the DoubleTree. However, we know that that's not enough, so we've got to put either a margin of error around that, or we've got to build our correct confidence interval is the more sophisticated way of thinking about this. So in order to do that, we need to figure out what z sub alpha over 2 is. That comes from the confidence level and our table. So you should know pretty well by now that 1.96 is the appropriate z sub alpha over 2 when alpha is 5%. In other words, when confidence is 95%. Last part, we fill in all these blanks for the standard error. Standard deviation is 17.2. We have to square that to get the variance. We divide by the sample size is 50. And over here, the standard deviation is 12.8. We square that to get the variance, and we divide by 50. All right, so I've got to warm my calculator up for this. So first I'm going to calculate the standard error, and that's going to be, let me see, 17.2 squared. Then I'm going to divide by 50. And I'm going to get 5.91. It's going to round it up to 5.92. Next, I've got 12.8. Square that. And I divide by 50 again. I'm going to get 3.28. I add those two numbers. Gives me 9.19. Then I take the square root, 3.03. So let's rewrite that where we're at. We were at 25 plus or minus 1.96 times 3.03. So I'm going to multiply 1.96. So I'm going to get 25 plus or minus 5.94. And now to write it in interval form, I put the lower number first. So 25 minus 5.94 would be 19.06 to 30.94 is the confidence interval. Now we should interpret this, we should write it in words, what we're saying. We're 95% confident that the difference mean cost of a Marriott room minus the mean cost, or I said the difference between the mean cost of a Marriott room and, pardon me, I should just say and the mean cost of a DoubleTree room is in the interval so roughly speaking, it's somewhere between $20 and $30. We can say we're 95% confident that a Marriott room costs $20 to $30 more than a DoubleTree room. So notice that I have to both give my confidence level and I have to give a range of possibilities. I can't give an exact number. And that is the usual for confidence interval type questions. We don't get single numbers, we get a range of numbers, an interval. All right, so that is part A of this question. Now, let me just skip ahead to part C, which is the one additional item in this section that we haven't really covered in our earlier discussion, because it's hard to talk about this unless we're looking at a particular example. So what I want to do in part C here is answer the question, are Marriott rooms more expensive than DoubleTree rooms? And the answer to this is that we're 95% confident that that is the case. Because 0 is not in the interval 19.06 to 30.94. So if 0 were in that interval, then 0 could be a possible difference, which means that there would be no difference, literally. If the difference were 0, there would be no difference between the two averages, between the two population means. But 0 is not in that interval, so 0 can't be the difference. So there actually has to be a difference between the two. a non-zero difference. So that's what we look for in answering these types of questions. Is one more expensive than the other? Are they different in price? Um, uh, and the the way we analyze that is to look whether zero is in the interval, the confidence interval. So we're going to do the same thing now in part B. What we're going to do is look at the confidence interval between the difference between for the difference in average room rates for the Westin and the Doubletree. So we're just going to compare in part B the Westin and Doubletree. So in this case, 165 minus 125 plus or minus. Now, since we are looking at 99% confidence, we use a z sub alpha over 2 of 2.58. And the standard error is the usual formula. In this case, the Westin is 22.5. We have to square it to get a variance. We divide by the sample size. And the Doubletree is going to be, again, 12.8. Square it, square the standard deviation to get a variance. There we go. All right, so we just grind this calculation out. This one part is easy. 165 minus 125 is 40, plus or minus 2.58 times. We have to fire up our calculator for this. 22.5. I am not going to go through every step. I am just going to quickly calculate a few things here. 10.13 if I round up. And the other one, we did this calculation before. I'm going to get 3.23. Add those two together. And then I take the square root. I should round up. Okay, so the interval I subtract, and I'm going to get 30.55, and then I add that is my confidence interval. This is my 99% confidence interval. So we're 99% confident that the difference between average room rates for Weston and Doubletree is in the interval between, let's just say, so roughly speaking, we're 99% confident that the difference is in the interval from between $30 and $50. So we're 99% confident that a Weston room costs $30 to $50 more than a Doubletree room. Now again, because that interval does not contain 0, we are 99% confident that there is an actual difference between the two hotels. The average cost of the room in the two hotels. So that's a handy way of comparing whether one thing is bigger than another on average. You can use it to say compare whether women are shorter than men on average. Any kind of comparison where you're comparing measurements. You can compare whether they're really different using this kind of reasoning. Okay, so that is the end of section 8.5. So you should study the examples inside the chapter I mentioned already. They're good examples, and then you should try some sample problems. There's the problem sets have been posted online, and then there are some additional sample problems you can take from the textbook. So please study that up. Our next quiz will include this and one final section from Chapter 8. So Chapter 8, the most important parts are, we're going to really cover 8.2, 8.4, 8.5, and 8.8. So that is point estimator, and margin of error, CI for population mean, confidence interval, of course. 8.5 is the CI for the difference between two population means. And 8.8 we will cover in the next lecture, but it is about the choosing the sample size. Okay, so 8.1 is just introductory material. There aren't any calculations in 8.1. 8.3 is point estimation. So sorry, that's not 8.2, that's 8.3. There we go. 8.3, that's really important. 8.1 and 8.2 are just introductory material. 8.3 is point estimators. That's really important stuff. 8.4 is super important. That's confidence intervals. 8.5 is the difference between two. 8.6 we are not going to cover. It is about the discrete version of 8.5. And that's unfortunate, but some items had to be taken out of this part of the course in order for us to add in chapter 11, which is really important. So we took out 8.6. It's really, really very, very similar to 8.5, so it's kind of a shame that we had to drop it, but we just dropped it for time. So we're not covering that topic in this course. And 8.7 we're also not covering. That's one-sided confidence intervals. We're not covering. That topic is a little bit more difficult to understand. So these things really are less important. I'm just going to put a big cross through them. They're not super important for quizzes and tests. The rest of it is. So far we have done 8.3, we have done 8.4, we've done 8.5, and we are going to cover 8.8 in the next lecture. All right, so see you there. Bye.